These are the solutions to November 2024 CCEA M4 Mathematics Examination Module. Okay, the first question says, Anne invested 18,000 in an account paying 4% per annum compound interest. After how many years will the value of her investment exceed, so that means greater than, £20,200. So what we want is to find the value of n such that 18,000 times 1.04 to the power of n is greater than 20,200. So just try n is equal to 1. That means 18,000 times 1.04 to the power of 1. And what that gives you is 18,720. Try n is equal to 2, so 18,000 times 1.04 squared, and that would give you £19,468.80. And then try 18,000 times 1.04 to the power of 3, and that will give you £20,247.55. So the answer is 3 years, because you had your 3 years here, your power was 3, and that is it. Okay, next question is a highest common factor. No, it's not. It's the lowest common multiple question. It says x is a 2-digit number. The lowest common multiple of x and 55 is 110. Find a possible value of x. So 55, you can use your fact button on your calculator, or the newer ones change the format, use product of primes. Put 55, press equals, and then that 55 is 5 times 11. And then your x, we don't know what x is, that's what we're trying to find. And your lowest common multiple is equal to 110. And 110 is 2 times 5 times 11. So that was 110. So you've got to find the smallest possible value of x, such that it has the lowest common multiple of x and 55 is 2 times 5 times 11. So that means you can't have a greater power than 1. You can't have more than 111 in my x. You couldn't have more than 15 in my x. But you also need to have a 2. So find the possible value of x. One possible value would just be 2 times 5, which would be 10. And if you can think about it, if I just was to do that all again, if I had 55 is equal to 5 times 11, and my 10, we'll just write it as 10. 10 is equal to 2 times 5. Your lowest common multiple of those, you take the biggest of each different kind of thing you have. I've got a 2, I've got a 5, and I've got an 11, and that is it. So my answer is just going to be 10. There's probably other answers. You probably could have done 11 times 2 as well, so 22 would have worked. What else would have worked? Well, that's really going to be it. That's all it's going to work for us. So your two options could be that 10, or you could have 2 times 11. 22 would have worked as well. Okay, right. Next one, it says the rectangle and triangle drawn below have the same perimeter. Remember what perimeter is. Perimeter is just the length around the outside. So this length around this outside must be the same as this length around the outside. That is it. So it says work out the value of A. So for the rectangle, the perimeter is, I've got 2 lots of 4A minus 3. I've got 2 lots of 3A. And my triangle, I've got 2 lots of 3A plus 2 and 1 lot of 2A minus 1. Just multiply that out and tidy up. 8A minus 6 plus 6A is equal to 6A plus 4 plus 2A minus 1. I would tidy up the left-hand side. It's going to be 14A minus 6. Tidy up the right-hand side. It's going to be 8A plus 3. Bring all the A's to one side. I'll bring all my A's to the left. And I have 3 plus 6, that should have been. 3 plus 6, you can see why I made that mistake, because it's going to be 9. And then it's going to be left-hand side, it's going to be 6A. A then is equal to 9 divided by 6, and I would leave that as 1.5. 9 divided by 6 is 1.5. Okay, next question. Zoom out in this one. It says 6 years ago, Henry and Jane each bought a new car. 6 years ago, Harry and Jane each bought a car. Harry bought his car for 25,000. In the first year, it decreased in value by 8,000. After that, it decreased in value by £3,000 each year. A graph showing the value of Harry's car is shown below. Okay, so there you can see Harry's car decreases by 8,000 in the first year and then by 3,000 every year. It says Jane bought her car for 19,000. In the first year, it decreased by 5,000 and it decreased in value by 2,000 each year. And what you've got to do is on the grid opposite, draw the graph showing the value of Jane's car each year. So it starts at 19,000. Let's just mark that on first. It says in the question, it decreased in value by 5,000. So 19,000 in 1 year then, it goes down to 14,000. It then decreases in value by 2,000 each year. So 2,000, 2,000, 2,000, and you can see there's the point at which it crosses, where they intersect. So let's just link those up. And this thing messes up quite often when I use a ruler on it. Apologies if it does. Oh, survived that one. And then you can see, there you go, roughly that's what you've got. The next part of the question says, use a graph drawn to write down the year when Harry's car and Jane's car had the same value. So they have the same value here, and that is year 4, so year 4. Okay, next question says, a doormat in the shape of a semicircle with diameter 82, calculate the perimeter of the doormat. So the perimeter is going to be the arc plus the diameter. So the arc is going to be, that is a half of a full turn. So a half times pi times your diameter plus your diameter. So it's a half times pi times 82 plus your 82, which is going to be, in this, what I'm writing down is an exact value, but I've also given that to 2 decimal places, 210.81, and that's going to be centimetres. Okay, next one we'll be on to question 6. Okay, question 6, we have got to calculate the area of the trapezium. The area of a trapezium, the formula for the area of a trapezium is this. It's a half, area is equal to a half upon A plus B, where they are your parallel sides, times the perpendicular distance between them. So in this trapezium, I need to find this wee h here. And I know in this triangle, this length will be 18 minus 6, so it's going to be 12 centimetres. And I know my hypotenuse is 15. So by Pythagoras' theorem, 15 squared equals h squared plus 12 squared. So I'm just going to say 15 squared minus 12 squared is equal to h squared. We better working out h is equal to 15 squared minus 12 squared and the square root. And that's a nice Pythagorean triple. H works out to be 9 centimetres. I've got what I need to do this question then. I know one of my parallel sides is a 6, the other one is 18, and I also know the perpendicular distance between them. I've now calculated this to be, what did I calculate to be, 9? So let's get cracking. So that's a half. Parallel sides, 6 plus 18. Perpendicular distance between them is 9. Fire that into your calculator, you'll get 108 centimetres squared. Next question. Pupils in a year group were asked whether they had travelled to Spain or France. Some information is shown in the Venn diagram. It says, so your overlap here in the middle is 7%. Tells you 53% had travelled to France. So that means the whole France circle is 53. So this bit must be 53 minus 7, which is going to be 46%. And then this bit here, the only bit missing is going to be your full amount, 100%, minus the 7, minus the 46, and minus the 16. And when I worked that out, I got 31%. Okay, next one. Tricky enough, we question this one. It says, a group of people were surveyed about the number of driving lessons they had before passing their driving test. So this is stem and leaf diagram. The results are shown in the stem and leaf diagram. So you can see the key here is 3/6 means 36 lessons. It tells you Alice passed her test. When her number of driving lessons is included in the stem and leaf diagram, the range increases by 2. So her value makes the range increase. That means her value is either less than 12 or greater than 51. That's what we get from the range increasing. But it also tells you the median decreases. So the median decreases, that means it must be on the lower end. So it's going to be in here somewhere. Okay? So it tells you then, well, we'll work out the current range. The current range before Alice's one is added. Current range is the smallest minus biggest minus the smallest. The current range is 39. That means the new range will be equal to 41. So Alice's score then her score made the range increase by 2, so her score, and it was on the lower end, remember? So it must be 2 less than our lowest value, so it's going to be 10. Okay, right. This one confused me a wee bit, I have to say, so I'm just going to show you why this works in. So again, so you've got your original, for the original amount, just to prove that this does work. For the original, your Q2, which stands for your median, is 24. So you've got 14 values, so your median is a 7.5 value. So first, second, third, fourth, fifth, sixth, seventh, 7.5 is going to be in here, so it's going to be 24. And for the new, you then have got 15 values, so 15 plus 1 is 16, divided by 2, your median will be the 8th value, and let's just do that out and just to see. So you can imagine she would have had a 0 in here, for that would have been 10, her score. So 1, 2, 3, 4, 5, 6, 7, 8, and that would take it down to 23. And you can see it says it decreases the median by 1. So her value did decrease the median by 1. So it does work. You don't have time, unfortunately, in an exam to do that, but just to give you a wee bit of confidence that my method that I've used does work. Okay, right, next one. What are we on to? Lovely wee algebraic question. Right, we've basically got a fraction equal to a fraction. It's not quite a fraction equal to a fraction, but I can make it a fraction equal to a fraction by doing this. And then if you're in this stage, you just cross multiply. So you'll have 18 minus x times 1 is equal to 3 times the 4 minus 2x. Multiply out, 18 minus x is equal to 12 minus 6x. Bring all the x's to the left-hand side. You'll have 6x minus x. Bring everything else to the right-hand side. So you'll have 5x equals minus 6, which means x equals minus 6 over 5, which is the same as minus 1.2 would be as nice a way to write it. You could write minus 1 and 1/5 as well, but that's fine. Okay, where are we? Question 10, is it? Yep. Question 10. In 2022, Rob sold his house for 227,700. This was a loss of 10%. He had bought the house from Lisa in 2019. She had made a profit of 15% in selling to Rob. Work out how much Lisa originally paid. Okay, first of all, I'm going to work out what Rob bought it for. So it tells you in the first line, Rob sold his house for 227,700, and this was a loss. So that basically means 227,700 equals 90%. So we want to find out what 100% is. So you're going to get from 90 to 100 by dividing by 9 and multiplying by 10. And when I did that, I got that Rob bought his house for £253,000. Now, Lisa tells us in the question, made a profit of 15%. So that means Lisa sold it to Rob. So Lisa, we want to find what Lisa bought it for. So she sold for £253,000. Okay, that's what she sold it to Rob. Remember, he bought it off Lisa. So £253,000 to Lisa was 115%, because remember, she made a profit of 115%. So we want to find what she originally bought it for, so her 100%. So I'm going to divide by 115 and multiply by 100. And I'm just copying down from what I did another time here, and I got 220,000. 220,000 was what she paid for originally. Okay, let's just check. Okay, so let's just do 220,000. She bought it for that. She increased by 15%, so that's what we're going to get. And then Rob lost 10%, so multiply by 0.9, and that should give us 227,700, if I have done this correctly. 220,000 times 1.15 and then times 0.9. And yep, it does. It gives you this thing up here, so I know I have got this one right. So there, your answer. Let me get rid of that. The answer then is 220,000 is what Lisa bought it for. Okay, lovely. Is this a Pythagoras question or a trig question? Let's see. Ladder is placed against a vertical wall. To be safe, it must be inclined at an angle between 70 and 80 to the ground. Is a ladder positioned safely? So basically, you've got to work out this angle. So you're just going to use SOHCAHTOA. And in particular, we're going to use tan, because tan, remember, is equal to your opposite over your adjacent. This is your opposite side, this is your adjacent. So let's say tan of theta is equal to 5.3 divided by 2.2. And your theta then works out to be tan to the minus 1 of that, which was 67.46 degrees. So it had to be between 60 and 70. So no, it is not safe. Not safe. Okay, right. Now that's how we look at this one. I made a mistake doing this one the first time. I made this far too complicated. Okay, let me just do the sort of bit that you can't see in behind just to explain this. Okay, a solid is made from a cylinder of diameter 14 centimeters and height of 8, with a smaller cylinder of diameter 5 centimeters on top. The total height of the solid is 12, so we'll need a wee bit of working out here. That total height is 12, that means that's 4 centimeters this wee bit. Calculate the total surface area of the solid. Okay, now clearly you've got a base at the bottom here, which is just going to be the area of a circle, which has a diameter of 14. And you've also got this bit here, okay, which I worked out by doing the whole circle, taking away the small circle, and then added on the small circle. Now what it would be a much smarter way of doing, just notice the small circle plus that circle with the small circle cut out just makes 2 of those bases. So, and also then I've got the small curved surface area, I'll do it vertically, and I've got my large curved surface area. So that's an absolute mess. So I'm going to say top and bottom, I've got 2 lots of pi r squared. So the top, that's going to be 2 times pi times 7 squared, which is going to be 49 pi, 98 pi. And then I'm going to have the small CSA, curved surface area, is, and the formula for the curved surface area is 2 pi RH. So for the small one, that's 2 times pi times my r, which is 2.5, times my h, which is 4. And so whatever that's going to be, sorry, 2 times 2.5 times 4 is 20 pi. And same idea, let's see if I can keep this on. The big curved surface area would be, again, 2 pi RH. But in this case, it's 2 times pi times my r, which is 7, times my h, get rid of that so it's not going over it, times 7 times my h, which is 8. So that's 2 times 7 times 8 pi, which is 112 pi. So let me just check what I've done here. Let's go through that again. I've got the top and the bottom. So the bottom bit was the bottom circle. The top bit was that whole thing, which makes one big circle. And then I've got this curve here and this curve here. I've got it all, haven't I? So we can say our total then, in terms of pi, perfect answer is going to be this. So 112 plus 98 plus 20, that's going to be 230 pi. And I have done this before, and I've got 722.57 centimeters squared. So you can see there's my answer in my horrible scroll, but there you go. Okay, right, we're on to getting on to the real tricky stage of this then. We're on to our few difficult things. Okay, right, stats stuff. Our first thing is, this is a group frequency table, shows the time taken by 50 workers to travel to work. So it says complete the table above. So the journey time, so these things are just the upper values, that's all it is. It's going to be a cumulative frequency graph. So just fill those in. So it's 25, 30, 35, 45, 60. Cumulative frequency is a running total. So 7 plus 11 gives you 18, plus 18 gives you 36, plus 9 gives you 45, plus 4 gives you 49, plus 1 gives you 50. Just check. Do your sigma f, total it up, and you should get 50. So if this and this match up, it looks like you're on the right track. Okay, so we've got our table completed. You then do your graph. Apologies, I meant to do this out already. So you're plotting this. Bear with me a wee second. Plotting this then. So the first one at 20, your cumulative frequency, yes, that was right. At 20, your cumulative frequency was 7. At 25, your cumulative frequency was 18. At 30, your cumulative frequency was 36. At 35, your cumulative frequency was 45. And at 45, your cumulative frequency was 49. And at 60, your cumulative frequency was 60. So very hard for me to draw this accurately here. So don't do what I have just done, because what I've just done, I'm doing sort of a series of small curves to link it up. So yours should be a smooth curve. That's what we've got. It says use your graph to estimate the number of journeys it took between 24 and 38. So you go up at 24 and across, and you go up at 38 and across, and you can see I'm doing this very, very roughly, and across. I'm not even going to do where it is because mine's not going to be right. But when I did that half decently, I got 57 minus 14, which is 43. You absolutely must have these lines. These are your working out. They're looking for these lines here. So make sure you've got those lines in, please. But that's how you do it. Okay, it just doesn't work very well on this, unfortunately. Okay, next one says, a light on a lighthouse flashes every 50 seconds. Light on a different lighthouse flashes every 65. After they flash together for the first time, how long will it be until they flash together again? Okay, this is a lowest common multiple question. So if they both flash together at a certain time, one of them, it has to be a multiple of both those numbers, 50 and 65, when they flash together again. So on your calculator, do your product of prime factors of 50, which is 2 times 5 squared. Your 65 then will be 5 times 13. And your LCM, take the biggest of each kind of thing. You've got 2's, you've got powers of 5's, and you've got 13's. The biggest of 2 or no 2's is 2. The biggest of 5 squared or 5 is 5 squared. The biggest of 13 or no 13 is 13. And that works out to be 650. So, and that is the same as 10 minutes and 50 seconds. So 10 minutes and 50 seconds. Okay, tricky question here. Oh, I wish I'd written this down better so I could see what I'm doing. It says lines BDF and DAE are tangents to the circle as shown. The lines BC and AC are equal. Angle CAE is 61, it's given. Use circle theorems to find the following angles, give a reason for each. So the first one is ABC. ABC is here. It's equal to 61 by the alternate segment theorem. Now, what I had always advised people to do is to not learn off the alternate segment theorem at all, but learn what it looks like. So there's your alternate segment theorem. If that's A, then that's A here. And the only other thing I would ever ask people to learn is to learn the other version of it. Whereas if that's A, that's going to be A over here. So you can see it is this type of one for the alternate segment theorem. So that is it. Okay, right. So I would just say that is 61 degrees, and that is because of the alternate segment theorem. That's all you need to do. Next one is DAB. Where is DAB? DAB is in here. I have to find this. Okay. Okay, right. Bit of work to do. Because this is an isosceles triangle, this will also be 61 degrees, which means this angle is going to be 180 minus 61, which works out to be 58 degrees. So it's 58 degrees, and I would just say because angle BAC is equal to ABC, which is equal to 61 degrees because it's isosceles. Therefore, the angle we want, which is DAB, is equal to 180 minus 61, which is equal to 58 degrees. Absolutely fine. Bound to be other ways of doing it. That's what I've done. Last one is the angle BDA. Where is BDA? BDA is here. And, yes, we're using isosceles triangles again. Is that right? BDA? BDA then. So this is equal to, same. Yep. This is equal to 58 degrees in here. So then you are, because they are isosceles triangles, and then you can say, what's that going to be then? We'll work it out then. That is going to be 180 minus 58 minus 58. So that's 180 minus 58, which is 64. And that should be it. Yep, I think that's it. Okay, so it's 64 degrees. And that's because, yep, so that's when they are the same, so that means because they are isosceles, yep, you're good. So that DBA is equal to 58 degrees. Therefore, BDA is equal to 180 minus 58, which is 64 degrees, and that is it. Question 16 says, a stone is dropped from a bridge and falls at a speed of v meters per second. The distance it falls, s meters, is calculated using the formula s is equal to v squared over 2g. V is equal to 14.2 meters per second, correct to 3 sig figs. G is equal to 9.81 meter per second squared, correct to 3 sig figs. Find the maximum possible distance the stone falls. Okay, so to make a fraction maximum, so we want to find the maximum s, we need to make the top line as big as possible. So v has to be at its maximum, and your 2 is just 2, but your g, the bottom line of the fraction, has to be minimum. So for a fraction to be maximum, you have to have maximum on the top and minimum on the bottom. And if it was the other way around, if it was fraction being minimum, you'd make the top line as small as possible, so minimum on the top and max on the bottom. Okay, so we want max on the top and minimum on the bottom. So you have got, top line is 14.2, but that was correct to 2 sig figs. So the upper bound of that would be 14.25. And then it's getting squared. Your bottom line, you've got the 2. And your G has to be minimum. So it was 9.81 to correct to 2 sig figs. So it would be 9.805 is what it's going to be. And then if you fire that in, it's going to be 10.355. Next question says, find the equation of the line perpendicular to y is equal to 3x plus 2, which passes through the point minus 3, 2. So this, my original line had a gradient of 3. So where that comes from is just a number in front of your x. Remember, y equals mx plus c, where m is a gradient and c is what's called the intercept. So that means a perpendicular gradient is a negative reciprocal. So what I mean by that, 3, you could write 3 as 3 over 1. And negative reciprocal means turn it upside down and then change the sign. So the gradient, perpendicular gradient, would be minus 1 over 3. So write that into y equals mx plus c. Then it becomes y equals minus a third x plus c. And then it goes through this point. So we'll just sub in that point. Minus 3, 2. So minus 3, 2 means my x value is minus 3 and my y value is 2. So we'll put them in. So instead of writing y, write 2. Instead of writing x, you write minus 3. And then just multiply, tidy that up. 2 then is equal to 1 minus 1/3 times minus 3 is going to be just plus 1 plus c. Then 2 minus the 1 is equal to c. 1 is equal to your c. So your y is equal to minus a third x plus 1. You should get your marks for that, but just in case the mark scheme has something different, they may also multiply through by 3, and that will be just minus x plus 3. So 3y, is equal to minus x plus 3. Okay, next page, we have got a right angle triangle. AB is equal to 3x minus 4. BC is equal to 2x plus 1. And the area of this triangle is 10.5. It says show that 6x squared minus 5x minus 25 equals 0. No idea. So it mentions the area. The area of a triangle is a half times the base times the height. So let's just fill that in. And the area of the triangle we know is 10.5. So that's going to be a half times the base, which is 2x plus 1 times the height, which is 3x minus 4. And then we'll go with that. So first thing I would do, I'd divide across by the half. Or sorry, you could say multiply both sides by 2. You'll have 21 it should be. And then we've got rid of our half, and is equal to just, and then if we multiply this out, sorry, let me write that in first, doing too many steps in one go. Okay, and then we're going to multiply this out just, so 21 is equal to 2x times 3x is 6x squared, 2x times the minus 4 is minus 8x, 1 times the 3x is 3x, 1 times the minus 4 is minus 4. Bring it all to one side, tidy up, you'll have 6x squared minus 5x minus 25. Oh, and that's what we'd wanted. It was indeed. Happy days. It says, hence solve, sorry, it doesn't say that, bear with me, where are we? It says, hence find the lengths of the lines BC, AB and BC. So first thing we've got to do is solve what we've just found, and then we'll come back to actually, we've got to find x first, and then we'll come back to what we know. So I'm going to use the sum and product method here. You could use your quadratic formula, but my sum is equal to minus 5, my product is equal to minus 150. And the two numbers that work, and let's just go through how we do that. Well, minus 1 times 150, minus 2 times 75, minus 3 times 50. What else we got? Does 4 go in? 150 divided by 4, I can't believe I'm doing that. 150 divided by 4 is not going to work. Divided by 4, 150 divided by 5 is going to be 30. So that's going to be minus 5 times the 30. 150 divided by 6 is going to be 25. So minus 6 times 25. And I think that's all is going to work there until that bit. Minus 10 would be times 15. And oops, not quite. That's not quite going to work. Minus 15 times 10 would work. Okay, right. Let's zoom in and think about why I was wrong then. So I incorrectly said that one would work. But if you add minus 10 and 15, you get plus 5. So that's why it needs to be the other way around. So it needs to be the minus 15 and 10. So important we see that. That's a very common mistake that I almost made. So 6x squared minus 15x plus 10x minus 25. Pull a 3 outside a bracket. 3x then times 2x minus 5 plus 5 upon 2x minus 5. So 0 is equal to 2x minus 5, 3x plus 5. That means x is equal to 5 over 2, or x is equal to minus 5 over 3. Okay, we're talking about length and stuff, so we're going to ignore. So my x is equal to 5 over 2. If you went back in the paper, it told you BC was 2x plus 1, and also told you that AB was 3x minus 4. So we're going to put in our x, which is, we'll write it as 2.5. I'll make it a wee bit easier for me to work with. So 2 times 2.5, and then plus 1, which is 5 plus 1, which is just 6. And over here, 3 times 2.5 would be 7.5, and minus 4 is going to be 3.5. So AB is 3.5, and BC, if I've done that correctly, is 6. Okay, next one. Lovely. Okay, simplify fully. Right, we've got to factorise. I'm going to do the working out for the bottom line, factorising of the bottom line over here. My sum is equal to minus 11. My product is equal to minus 12. And that's a nice easy one. My two numbers are minus 12 and 1. So that's 3x squared minus 12x plus x minus 4. And that's 3x times x minus 4 upon 1 upon x minus 4. So that is x minus 4 upon 3x plus 1. So that's the bottom line factorised. Top line, we'll take a couple of steps to factorise it. Pull out a 2 first of all. Your bottom line is x minus 4 upon 3x plus 1. And then that's 2 upon x minus 4 upon x plus 4. And that's all over x minus 4, 3x plus 1. And then that is 2 times x plus 4 all over 3x plus 1. Sorry, I forgot to say how I got that. You can see your x minus 4's cancel, and that is it. And that's all that can cancel. Big mistake people make is they try and cancel the x's out of the last bit. You cannot cancel them as they're not multiplying everything throughout. Okay, question 20, another lovely algebra question. Solve the following equation and give your answers to 2 decimal places. Right, this is one which is going to lead to, algebraic fraction, which is going to lead to a quadratic. So what we do is take a common denominator. Before we do that, let's just explain why this is what we're doing. If I had 1 over 4, for example, plus 2 over 3, my common denominator would be 4 times a 3, those two things multiplied, and I'd have to do my 1 would get multiplied by 3, and my 2 would get multiplied by 4, or whatever way around you want to write that. Same idea if you had a over b plus c over d, and you took a common denominator would be bd, and your top line would be ad plus bc. So if you understand this in particular, you can do any of these adding or subtracting fractions. So over here, common denominator is going to be 3x plus 1 upon x minus 1, and the top line is going to be, it is going to be the 2x gets multiplied by x minus 1, and the 4 gets multiplied by 3x plus 1, and that is equal to 5 over 2. Okay, that's an absolute mess. Let's tidy up the top line. If you tidy up that top line, you're going to get 2x squared minus 2x plus 12x plus 4. Bottom line, I think I would still write the bottom line as it is, to be honest. Could multiply it at this stage, but I think I'll leave it here. There's a lot of this bit. You could do multiple things, multiple ways of doing it. Next thing I would do is I would tidy up the top line. That's 2x squared plus 10x plus 4. And then I would multiply across by the 2 as well. So this 2 here is coming across, and this denominator here is coming across and multiplying. So we're going to have 2 upon that is equal to 5 upon 3x plus 1, x minus 1. Okay, let me zoom in on this and get cracking on this. Okay, multiplying out time, so the left-hand side is going to be 4x squared plus 20x plus 8. The right-hand side, don't multiply it by the 5 just yet. Multiply 3x times x is 3x squared. 3x times minus 1 is minus 3x plus an x minus a 1. Tidy up then, that's going to be 5 upon 3x squared minus 2x minus 1. Tidy up again by multiplying out. You'll have 15x squared minus 10x minus 5. And then that's equal to 4x squared plus 20x plus 8. Bring everything to the right, and you'll have 11x squared minus 30x. I'm just checking my working out as I go along here. Minus 13. Okay. You then can use your quadratic equation. It mentions as well, it mentions here the 2 decimal places. If it mentions giving your answer to 2 decimal places, I wouldn't waste time even trying to factorise. I would just expect that it's not going to work. It's not going to factorise nicely. So I'm on to my quadratic equation. So minus b, so that's going to be 30, plus or minus my b squared. Put that in a bracket, especially when you're putting it into your calculator, where a lot of people will go wrong. So use brackets here. Brackets are your friend. And all divided by 2 times your a, which is 11. And I'm just copying down what I've done, so hopefully I've done this correctly. 0.38 to 2 dp's is one of my answers. And the other one was 3.11 to 2 dp's was my other answer. So tough question, 8 marks. So they're not giving away these marks. If we give you 8 marks, they're going to make you work for it. So a fair bit to do there. Okay, right. We have a massive long histogram question now. Second last question. Nobody's favourite, histograms. It says, Year 8 pupils were surveyed on how much time they spent doing homework on one night. The incomplete table and histogram show some information on this. No student spent longer than 80 minutes on their homework. So you can see you've got a wee bit of a table and you've got a histogram as well. So, right. What we know first of all, the first bit of information I'm going to use is that they tell you in the this frequency, first one is 100. So this area must represent 100. So the width of it is 25. So the width of that first bar, all the way along there is 25. So that means to get this value here, I'm going to do 100 divided the frequency divided by the width, which is 25, and that's going to give me 4. So that's equal to 4. Once you get your 4, that's the hardest bit done. Then that 2 down is going to be 3, another 2 down is going to be 2, another 2 down is going to be 1, and then that takes me to 0. So there's your frequency density. You're then ready to go. So you can fill in the rest. So here, from 25 to 35, we're looking at this one here, from 25 to 35, the frequency, the width is 10, and the frequency density, if you zoom in here, the frequency density is 3.6. Yep, 3.6. Oh, I've lost it. 3.6. So it's just going to be 36. The last one was 60 to 80, and this area here is going to be, the width is 20, that's 20 here, and the height there is 4, so it's just 20 times, sorry, it's not 20, it's 20 times 0.4, I should say. So this last one is going to be 20 times the 0.4, so it's just going to be 8. So there's your frequency table filled in. Okay, the other thing we've got to do is we've got to draw another couple of boxes in here. So we're going to look back at our table and do that. So from 35 to 50, so there's 35 to 50, it was a frequency of 24. So the frequency density for this one is the frequency divided by the class width. So frequency 24 divided by 15, which gives me 1.6. So 1.6 roughly, I'm doing this, well, I'll try and do it with a ruler here. So 25 to 50, 1.6 is going to be the here. I will shade mine in so that we can see them. It's very hard to see on this screen. Okay, I'm just shading this in. I wouldn't shade it in an exam here, but this is just so you can see it. You good people. Okay, so that was that one. The next one, it was 50 to 60, which is 10. And so the frequency density is going to be the frequency 12 divided by the width 10. So that's 1.2. So that was from 50 to 60 is just 1.2. So again, 1.2 would be here. This ruler's working quite well on this. This is where I speak too soon, and I'll shade that one again so you can see it. Oh dear, gone over a wee bit. You know what I mean. You can see it there. Beautifully done. Right, so you've got your bars. Okay, use the table. Sorry, it asked us. It asked us. I've already done this next page. It told us use the table to complete the histogram. Done. And use a histogram to complete the table. Done. Okay, right. Now, what they've done, they've been very smart here the way they've done this. They've given you a new histogram. So that means they've done that just to save themselves a wee bit of time, a wee bit of effort, so that you haven't got you're not working with an incorrect. You draw on histogram, you've got a correct one. Okay. Tough question. I thought this one. It says, the following histogram shows the time spent on homework by year 12 students on the same night. It says 36 year 12 students spent less than 60 minutes. So that means this whole area here, whole two areas here, sorry, are equal to 60. So we're going to have to work out what this is. So what you've got here, let me go through this again. You imagine what you've got. If I consider this to be one box, now there's oodles of different ways of doing this. So if that's one box, that's in two boxes. That's three boxes. And this is 0.3 of a box. So 0.6 of a box. So from this, what you've got from this, and this is my working out for this part, that's 3.6 boxes. It tells you in the question was equal to 36 people. Therefore, one box, just 36 divided by 3.6 is going to be 10. Okay, that means what have I got then? Sorry. Yep. So that means that's going to be equal to 10. So here, that's what one box is equal to. We need to work out the frequency density. So that's 20 by what gives you 10. So 20 by 0.5 would give you 10. So that's how I've worked out that this is 0.5. Okay, so that's a wee bit of a mess really how I've worked it out, but that's how I've worked it, that's 0.5. So once you've got that, I would write in what my rest of the frequency densities are. So 0.5 is 5 wee squares. That's going to be 1. That's going to be 1.5. That's going to be 2. That's going to be 2.5. That's going to be 3. That's going to be 3.5. Okay? Right. The question then asks you, now we're ready to do the question. The question says, find the mean time spent by these people. So what we need to do is find the frequency of all these things. So I'm going to say the groups, first of all, and then we're going to find the midpoint of each group, midpoint x. You're going to find your f, and you're going to find your fx, because remember what mean is. Mean is your sigma fx divided by sigma f. Okay, the groups, let me get those in first. You can see we go from 0 to 20. We go, we go from 20 to 60. We go from 60 to 90. We go from 90 to 120. And we go from 120 to 180. Let's get the midpoints done. We don't need to look at our table to do that. To do the midpoints, add the two limits, 0 and 20, and divide by 2. So it's 10. 20 plus 60, and then divide by 2 is 40. 60 plus 90 is 150, divide by 2 is 75. 190 plus 120 is 210, divide by 2 is 105. 120 plus 180 is 300, divide by 2 is 150. And then the frequencies, okay, to get the frequencies, I think it's a frequency density times the height. There's going to be a lot of jumping about here, I'm afraid, folks. The first box was width of 20, sorry, it's a frequency density times a width, I should say. So it's 20 times 0.8, which is 1.6. Sorry, I'm going to zoom in here. You can just check, you can check these on the mark scheme yourself. Next one's going to be, it was from 20 to 60, so that's 40 times 0.5, which is going to be 20. Next one is 30 times 1.8. which is 54, and 30 times 2.8, which is 84, and 60 times 0.2, which is 12. And the sigma f, which we'll need in a wee minute, is 185. Okay, so that's where we got those. Just to remind you, we'll just look at the last one there, well, because I can see it on the screen. This frequency here, the width of that was 120 to 180, which is 60. The height of it was 0.2. 60 times 0.2 is 12, and I've just done that for all of those, I should say. And then we do our fx. So your fx column is your x column times your f. So 10 times the 10 times this. Sorry, that should say 1.6. That should say 16. 10 times that's 16. So 10 times the 16 is 160. 40 times the 20 is 800. 75, let me just check this one, I'm doubting myself now. 75 times 54 is, yep, sorry, I was right there, 4,050. And then 105 times 84, 8,820. 60 times 0.2, sorry, not 60 times 0.2, 150 times 12 is 1,800. And let me just check again, adding those all up. And yep, I've got that. I've either got it wrong twice or I've got it right. And that's what I've got. Okay, so your mean, remember what your mean is. Let's just write the formula down here. Sigma fx divided by sigma f. So in this case, 15630 divided by 186, which is 84.03 minutes. Lovely. Right, okay. The next bit is a stratified sample. It says a stratified sample is taken from the year 12 students. Given that 14 students are sampled from the 90 to 120 group, calculate the number of students in the sample. Okay, right. The total from the 90 to 120 group was what? So from 90 to 120, the total was 84. So that's where we've got that from. So the total from that was equal to 84. So that means the fraction sampled is 14 over 84, and that's going to be consistent. And that's my fraction sampled. So we're going to multiply that by our total of the population. So that means 4 times 186, which works out to be 31 people. Okay. And the last bit of this one says estimate the number of students in a sample who spent more than 150 minutes on the homework. Okay, right. We need to work out first of all the total people who were greater than 150. So let's just work that out. So from your diagram, there's 150 is here. So this wee shaded area, what it's going to be, it's 150 to 180, so it's 30 wide, and it's times 0.2. That's going to be 15 people. Oh, it's not 15 people at all, that's nonsense. 30 times 0.2 is going to be 6 people. Apologies, so it's 6 people, so let's just write that in again properly. Right, so 150 people, the total number of people greater than 150 was 30 times 0.2, which was 6. That means the number in the sample, it's in the same proportion as earlier on, so it's 14 over 84, and then times 6. And does that work out bang on 114 divided by 84 and then times 6? Yep, it works out as exactly 1. So if I got that in an exam, I'd be pretty confident it's right. There we go. Okay, I think we're on to our last question now. We are indeed. Very tough histograms question. I'm not a big fan of histograms questions. They're actually harder at GCSE Mathematics than they are any other level of mathematics, which is weird. Okay, right. An ice cream cone is filled with chocolate at the bottom, as shown. So the radius of the circle at the top of the chocolate is r. Find and the radius of the circle at the top of the cone is 3r. The height of the ice cream cone is 18, and the distance between the top cone and the chocolate is 12. The volume of space left in the cone is 196. Okay, that's 6 centimeters in, this wee height. Let's just write down a wee formula here. So the volume of space left in the cone. The volume of space left in the cone is this bit. And this shape is what's called a frustum. So a frustum basically is a cone with the pointy end chopped off it. So your volume of a frustum is the volume of the big cone minus the volume of the small cone. Now the way I like to write that is, then we'll fill that in. So we know the volume of the space is 196. So that's the volume of the big. So that's pi, a third pi big R squared times big H, minus the volume of the small n is pi times small r squared times small h. So that's clearly the big cone. I've used capital letters. The small cone, I've used lowercase letters. Right. And then if you look back, then that's 196 is equal to, you're told in the question that big R, the big radius of the cone is 3r, so that's brackets 3r squared. The height of the big cone is 18, minus a third, times, and the radius of the small cone is r, the height of the small cone is 6, so it's just r squared times 6. Okay, that is a bit of a mess, let's tidy it up. So 196, I'm going to show up my steps here. First of all, a third times 18 is just going to be 6. And then 3 squared gives you 9. And r squared gives you r squared. And then minus, oh sorry, I forgot to do that. Next bit then, you've got a third times 6 is just going to give you 2. And that's pi r squared. And 196 then is equal to 54 pi r squared minus 2 pi r squared, which gives you 196 is equal to 52 pi r squared. Wee bit of working out, 196 divided by 52 pi, use your fraction button, equals r squared, which means r is equal to 196 over 52 pi, and the square roots. Okay, and whatever that is, I don't think I've used my calculator once yet here, and it says, well, what does the question say? I haven't even looked at the question. The question says calculate the diameter of the cone. So the diameter of the cone means the original cone. So you're looking for 6r. So the diameter is 6r. That's what it's going to be. So we know then the diameter, so just go from here. Diameter is 6r. So it's going to be 6 times the square root 196 over 52 pi. Which in this case, I think I've written this down as 6.57 to 2 decimal places. And that's us done. Okay, that's the end of the exam there. That was a tough enough 7-mark question at the end. And just read the question at the end. It said the diameter of the cone, so you don't just find r, you find what 6r is, because it's the diameter of the whole cone. Done.